change. It is the last lesson of this unit, which means that tomorrow we are reviewing and Wednesday we are testing. Yep. Super serious. All right. The behavior of the graph of a function for a very large value of x. So we will either take x to positive infinity or negative infinity, and that is known as end behavior. We will use end behavior again, and when we talk about it again, we're going to use limit notation, but that's going to be later. All right, so this will not be the last time you see end behavior. And we have 4 different cases for my end behavior, depending on the degree and the leading coefficient. Now remember, we've already talked about the degree. The degree is the highest exponent. The leading coefficient is going to be the number with that exponent. All right, so let's talk about how we're going to read this notation. So this says as x approaches negative infinity. All that is talking about is the left side of my graph. And as x approaches positive infinity, that is the right side of my graph. It doesn't matter the order. So I think on my poster over here, I have the right side first. So I have x approaches positive infinity first. So just kind of be mindful that you're actually reading and you're not just copying. Because the order doesn't matter, but you do have to match it up with the correct f of x. All right, so if we are even with a positive leading coefficient, an example of that would be like 2x squared, right? And the end behavior is going to go up and up like a quadratic, right? And x squared is like a u. The ends of your graph, they're both shooting upward. All right, and this works for any even exponent with a positive leading coefficient. The ends of the graph are going to go up and up. We don't know what's going to happen in the middle, but we do know that the end will be going to positive infinity. Okay, so I can say that the left side of my graph is going to positive infinity, and the right side of my graph is also going to go positive infinity. All right, so the negative and x approaches negative infinity, that's talking about the left side, and as x approaches positive infinity, that's talking about the right side. Your answer is what your graph is doing, what f of x is doing. Because the left side, the arrow is going upward. So the y values are going up. And then this one, the y values are also going up. Okay, so let's talk about same type situation, but with a negative leading coefficient. So say it was like negative 2x squared. Well, what happens to your quadratic when the front number's negative?
It goes down.
It goes down. It flips over and it's a sad face, right? This guy is still the left side. This guy is still the right side. So as x approaches negative infinity, that is the left side of my graph. That left side is going down. And as x approaches positive infinity, that is the right side. And the right side of my graph is also going down. And so it'd be negative infinity, negative infinity. All right, so the way that I have this memorized, if it is an even degree, I think of a quadratic, so I know my end behavior is going to go in the same direction. So even degrees will either both go up or both go down. Positive goes up, negative goes down. All right, the odd ones are a little trickier. The odd ones are going to go in opposite directions. So one will go up and one will go down. So I like to think about a linear graph, like 5x plus 1. All right, it's like a linear line. The right side would go up, the left side would go down. Now this works for any odd degree, like a cube or a fifth. We won't know what happens in between, but I do know that the end of the graph, the right side would go up and the left side would go down. Negative infinity is still talking about the left side. Positive infinity is still talking about the right side. So in this case, as x approaches negative infinity, the left side of my graph, what is my graph doing?
Negative infinity.
Negative infinity. And as x approaches positive infinity, the right side of my graph, what is it doing?
Positive infinity.
Positive infinity. All right, so we're going to keep everything the same, except we're going to make that leading coefficient negative. Which is still a linear, but it would be a negative slope. So I kind of think about something like this. Now remember, this works for all of the odd functions. We don't know technically what's happening in the middle, but I know that the right side will go down and the left side will go up. So all of this stuff here is the same. So this is still the left side, the negative infinity. This is still the right side, the positive infinity. So as x approaches negative infinity, what is f of x doing? Going up, and as it goes to negative or positive infinity, it would go down. All right, so odd functions, they will go in different directions. They will be backwards. All right, make sense? All right, what I'm going to do now before, oh wait, no, we have examples. Just kidding. All right, so find the end behavior for the function. Yes, so what are they both doing? Going down. So both of your end behavior is going to be negative infinity, negative infinity. They're both going down, so the ends of your graph are going to go down. What about 61? What are they doing? Both going up, left side and right side. All right, 62 is a little different because yes. So as x approaches negative infinity, is that the left or the right side? Left. So this side's going up, and as x approaches positive infinity, down to negative infinity. All right, so that's looking at graphs, but we also can just look at functions. So let's look at 63. On 63, all I care about is the biggest exponent. I don't care about any of this other stuff. So this guy here is even. The 2 is even with a negative leading coefficient. Because it's even, they're going to both go in the same direction. And then since it's negative, they're both going where? Down. So negative infinity, negative infinity. All right, 64. All right, so now we're going to start talking about some of these tricky ones. So x minus 1 cubed is the same thing as x minus 1 times x minus 1 times x minus 1. Now, do you want to multiply all of this out? No. And since we only care about the biggest term, I can just multiply all the big guys together. What is x times x times x? X cubed. And that's going to be the biggest term, the biggest degree. I don't care about any of the other stuff because that doesn't tell me anything about the end behavior. And of course, the leading coefficients, 1 times 1 times 1, would just be 1. Does that make sense? Okay, so we are talking about an odd degree with a positive leading coefficient. So as x approaches negative infinity, the left side is going to do what? Go down, and the right side will? Go up.
When we're writing the stuff on the homework and stuff, do we have to write out all of that?
Yes.
All that notation?
Yeah. Yes, that notation you do have to write every time, which is kind of annoying.
What, x to negative infinity as f of x to what?
Yeah.
Oh.
So look, there it is. All right, so when you do get to your homework, you do have to specify. Now I think on your, hold on. We've been doing the left first. Okay, so on your homework, you do have to specify as x approaches negative infinity, f of x is doing what? And as x approaches positive infinity, f of x is doing what? So you have to tell me what the left and the right side are doing. If you just put the infinities down, I don't know which one you're talking about. So you do have to write everything that I wrote here in red. You have to write that every time. Okay. On 65. So I don't care about this plus 2 at all, because that's a smaller term. But I do need to multiply the negative 1/2 x cubed times the x to get the end degree number. And so really after this all gets multiplied, it'd be x to the 4th. Yes, so because it's even, we're going in the same direction. My leading coefficient is negative. So both negative. All right, and then my last one of these guys, I do not care about the 1 because that won't give me the leading term. What I care about is the biggest exponent, which is going to come from when I multiply these guys together. Now, make sure you keep this negative. That will affect your leading coefficient. So that negative has to stay because we're multiplying 3 times negative 1, which is going to give me negative 3, and then x to the 5th. All right, so we are odd and negative. So the left side is going to go to infinity, and the right side will negative infinity. And if you're taking the test and you ever brain fart or you just are lazy and you don't want to get your notes out, you also could look at my poster over here for end behavior. Okay. So let's talk about average rate of change now. All right, so a secant line is a line joining 2 points of a function. Finding the slope of the secant line through these 2 points is going to give you the average rate of change. AROC. All right, so I do normally abbreviate average rate of change as AROC. But all that is slope. So don't overcomplicate that. That is an Algebra 1 problem. All you're doing is finding slope. y2 minus y1 over x2 minus x1. I know they drilled slope into your brains over and over again when you took Algebra 1. All right, so on these examples down here, if I want to find the average rate of change over this interval, I need to figure out what my y1 and my y2 are. So I'm going to look at the graph. When x is negative 2, what's the y value? Negative 2. And when x is negative 1, what's the y value? 2. And then when I put that into my slope formula, 2 minus negative 2 over negative 1 minus negative 2, I get 4 over 1, which is going to be 4. So my average rate of change is 4. And what you just found is AROC and the slope of that line. So if you were to sketch a line, do you see my line I've sketched to those 2 points? Do you kind of see how that slope is a slope of 4? Rise 4, run 1. All right, so we're going to do the same thing here. So if x1 is 0, what is y1? 0 at 0, And if x2 is 1, so at 1, what's my y value?
Negative 2.
Negative 2. All right, negative 2 minus 0 over 1 minus 0 is going to give me negative 2. And if you were to draw a little line between these 2 points, you can kind of tell that that slope is negative 2. All right, can I flip?
Dude. Every time I'm writing something.
All right, on 69, we are also finding the average rate of change, which once again is just slope. Now, this is where something that people get messed up on. When it's talking about an interval, they're x values. This is x1. This is x2. All right, so my x's are 1 and 3. You have to find your y's. How can I find my y's?
Go to the graph.
We don't have a graph though.
Oh.
But we have a function. So I'm going to plug in 1 into my function. So 1 cubed minus 3 times 1. So 1 minus 3, which is going to be negative 2.
Yeah.
And then I'm going to plug in 3 to find my y2. So 3 to the third power is going to be 27 minus 3 times 3, which is going to be 9, which is 18. Once you get your y's and you have your x's, then you can put it in the slope formula, y2 minus y1 over x2 minus x1, which gives me 20 over 2. So my final answer is going to be 10. Okay, are we okay with average rate of change? It is just slope, just a different vocabulary word. Okay, the last question here deals with this graph. All right, and we are going to write the intervals for this graph. Now, you do have a question like this on your test, and if I were you, I would get a highlighter, and I would highlight your function. So you can kind of see the two different functions. All right, so for my domain of f and g, do you have any endpoints?
No.
No, they're arrows. So what's my domain going to be for both of them?
Well,
All real numbers. So for f, it's going to be negative infinity to infinity, or you could put the all real number symbol. And for g, it's going to be negative infinity to infinity. All right, on part B, it says find the values when f and g equals 0. All right, these are your x-intercepts. So I drew a green line on my x-axis. F is the blue function. When does the blue function hit my x-axis?
-9.
-9. When does the g function, which is red, when does that one hit the x-axis?
-6 and
-6 and -2. And it's kind of hard to tell, but 13. That one will extend and hit at 13, I think. I won't put one tricky like that on your test. Okay.
I'm so highlighted.
For part C, it says find the values where f and g equal each other. So when you're looking at your graph, what am I going to be looking for? Yes, the intersection. So we're going to intersect here. Which number is that at? -8. Where's this one at? Ish. 1. And this last one here is 7. So -8, 1, 7. All right, we're going to hop over here to H, I, and J real fast. Yes, increasing and decreasing. So first we're talking about f. F is the blue function.
So negative infinity.
Yes, so we're going to increase from negative infinity all the way to -7. And where else?
-4 to 0.
Negative infinity to -7. -4 to 0. And
4 to infinity.
yes. So when you're looking at your blue function, if you're walking along it from left to right, any of the places that go up, so from negative infinity to -7, then we decrease. We start increasing again here at -4 all the way to 0, then we decrease, and then we increase from 4 to infinity. All right, G. G is the red function. When is G constant, which is a straight horizontal line?
Oh, -1.
2, 3. Yep. So the straight horizontal line, -1 to 3. And then we're going, still looking at the red function, still looking at G. When is G decreasing? So start on the left side. I'm going to zoom in. G. So red, you're doing the blue one, which is, you're right for the blue one. But for the red one here, we're negative infinity, and we're going to decrease all the way to what?
-4.
-4. So this whole time here, you're decreasing all the way to -4. And then there's one other interval where you're decreasing.
It's
3 to negative. Or 3 to infinity.
3 to infinity. Good. So negative infinity to -4. 3 to infinity. Okay, and then this kind of irritates me, but we're going to do L because L is another decreasing one. But it's the blue one, so now this is what you were talking about. So we would say from -7 to -4. Yeah,
And then 0 to 4.
and then 0 to 4. Okay, so that takes care of all of the increasing and the decreasing. So now I want to talk about these three right here where it says greater than 0, less than 0, and greater than 0. Remember, 0 is your x-axis. So if I'm looking for the interval where g is greater than 0, that's where you are above the x-axis. All right, so both F and K are talking about above the x-axis. Since g is less than 0 here, problem G, says f of x is less than 0, this one is below the x-axis. Okay, so I'm going to move this over here so we can look at the graph, and then I'll write the intervals. Forgot what the question was. All right, so on letter F, when we want to know when g is greater than 0. So g is the red function. So are we greater than 0 from the start?
Yeah.
Yes, we are above all the way to what number?
-6.
So we're going to say negative infinity to -6, and then we're below, and then we are going to pop back up greater than 0 from -2.
To infinity.
Well,
No, until
till 13. All right, so that one was F. Yep. So negative infinity to -6, and then -2.
Wait, you said it was F.
Wait, what?
The same mistake.
Oh, are you saying, oh, F?
Letter F.
Letter F, not F of X.
Yes, letter F. Sorry.
What?
Okay, so we just did the red function, the g of x. Okay, so let's do the f function now. Yeah, actually, that's
why.
poor planning on my part. So when is the blue function greater than 0? So we start off below the x-axis. When do you pop up above the x-axis? -9 all the way. Yes. All right, so if we're talking about when f of x is below the x-axis,
Negative infinity to -9.
yep, negative infinity to -9. All right, and then my last two questions are talking about when is f of x greater than g of x, or when is f of x less than g of x. So f is the blue function. When is the blue function on top of the red function? So does it start off on top? No. What number does it start being bigger? -8 all the way to what?
1.
To 1. So we're going to say it is bigger from -8 to 1. And then there's another interval.
And then
6.
7.
7.
7 to infinity.
7 to infinity. So it also becomes bigger right here at 7, and then we're assuming to infinity. So when would f of x be below g of x?
From 1 to 7.
1 to 7, and then there's another one.
And negative infinity to -8.
Yes. Okay. Does that make sense?
Do we have to write the use for those?
No, I don't really care about the use. You can write them, though.
I've been
All right, questions, comments, concerns? Tomorrow you're going to review. Wednesday you're going to test.
Very good.